Okay, let's see. We're going to take a look at a couple permutation and combination questions here in this video. There are a couple different ways we can handle permutation and combination problems. Right now, if you have a calculator in front of you, one of the ones like we use in class, I want you to turn it on. If you don't have it, pause the video and go get one. And anyhow, you want to turn it on. And if you look at the second row of keys, there's a button that says PRB. So hit that button, and you should see NPR and NCR. The NPR is underlined, and to change what's underlined, you can use the arrow keys in the upper right-hand corner of your calculator to go left and right. And you should also see an exclamation mark for factorial as well. So let's say we wanted to use the NPR button. And let's say we wanted to figure out 5 NPR 2, which basically means that we want to know how many permutations are there of 5 objects taken 2 at a time. What we'd do in our calculator is we'd hit 5, we'd hit that PRB button, we'd hit equals because NPR is already underlined, and then we'd hit 2. And it should look in your calculator just like it does in the screen right now. And then if you hit equals, it should say that that is 20. Okay, now another way to do this same exact problem would be to just start at 5, since that's how many objects we have. And this 2 tells us how many numbers to multiply together. So we're going to multiply 5 by the number right after 5 or right below it, which is 4. And that gives us 20 as well. Okay, so you could do it 2 ways, using your calculator, or you could do it pen and paper way, 5 times 4 like that. Okay, for combinations, let's say we had 5 NCR 2. We'll go with 2 again. You could use your calculator, and you could type 5, hit the PRB button, scroll over with the arrows to NCR, and type in 2. And if you do that, you get 10. Okay. Or you could do it paper and pencil method, which you start out with 5 and you go down to the next number, 5 times 4, and multiply that. And then, just like we did with the permutations, but this time you want to divide by this this number right here by this 2. So we're going to divide by 2, and that gives us 20 over 2, which ends up giving us 10. So that's the way that we could do that using pen and paper. So let's see here. Let's maybe erase this. I'll pause it to erase what we have. All right, let's look at one other example before we actually do the problem. Let's say we had 6. Whoops. Let's say we have 6 objects, and we want to know how many permutations are taken 4 at a time. So calculator, you can do this real quick. 6 PRB, hit NPR, hit 4, gives you 360. Paper and pencil, you'd start with 6, and you have to list, because of this 4 right here, you have to list 5, 4, and 3. That gives us a total of 4 numbers that are being multiplied together. And when we do that, 6 times 5 times 4 times 3, hit equals on your calculator, gives you 360. So you can do it either way. If we had 6 and we wanted to know how many combinations taken 4 at a time using the calculator, we can type 6 PRB, go over to NCR, hit 4, hit equals. It gives us 15. Paper and pencil, you start out like a permutation, so you list your 4 numbers. But then, since we have 4, for the combinations, we have to remember to start at 4 and then multiply all the numbers down to 1. So 4 times 3 times 2 times 1. And let's see, where'd my pen go? That gives us 360 divided by, what would that be, 24. And 360 divided by 24 is 15. Okay, so that's for combination. So you can do it either way. Alright, so let's actually tackle this problem. It says that Frank has 5 cards, has the face cards and aces of a deck of cards. How many permutations and combinations are there of these cards taken 5 at a time? This is actually two different questions in one. And then it says, remember that a deck of cards has 4 suits containing an ace, king, queen, and jack. All right, so how many cards does he have if he has the face cards and also the aces? Well, if there are 4 cards, ace, king, queen, and jack, and 4 suits, 4 times 4 tells me that this guy has 16 cards that he's using. All right, so we have to keep that in mind. So first for permutations, this is our permutations here. And I'm going to do this the long way. You can use your calculator if you want to, but I'm going to do it the long way in case somebody doesn't have a calculator that does permutations and combinations with them at the time. So we're starting out with 16 cards, and it's a permutation, so we have NPR. That's what you'd write in your calculator if you were using it, and they're taken 5 at a time. So my work is going to be to start at 16 and then multiply by the next 4 numbers, which would be 15, 14, 13, and 12. That's 1, 2, 3, 4, 5 total numbers. 16 taken 5 at a time. And when we do that, we get, let's do the math here. Whoops. Kind of big number, 524,100. Whoops, forgot my 160. So I'll write that up here. Permutations is equal to 524,160. I'm going to pause this to erase. Alright, so now we want to also figure out how many combinations there are. There we go. So, for combinations, we have 16 NCR5. And we'll do the work here. We take 16 times 15 times 14, 13, and 12. Is that 5? 1, 2, 3, 4, 5 numbers. Divided by, since we have 5 numbers, we start at 5 and 5, 4, 3, 2, 1, all the way down to 1. And so we have 524,160 on top. We know that from our last problem. 5 times 4 times 3 times 2 times 1, I believe that's 120. Yeah, it is. And when we divide, we get 4,368. And I'm going to check here with my calculator to make sure I did that right. So I'm going to type 16 PRB, go over to the NCR, hit 5. Yeah, that's the right answer. Okay, so for the number of combinations, we have 4,368. We'll put a comma in there. Doink. Good to go. Okay, we have 2 more problems we're going to take a look at here, and that should finish us up for the permutations and combinations. You have to be careful when you read these to decide whether it is a permutation or a combination problem. If the order matters, then it is a permutation. If the order does not matter, it's a combination. So let's read this problem here. It says, in a raffle, 5 winners will be randomly chosen. Each winner will receive the same prize. As soon as I see that they're going to receive the same prize, that tells me that this is probably a combination problem. Then it says, how many different ways can 5 people be chosen if 23 raffle tickets are sold? So basically what this comes down to is we have 23 different raffle tickets, and we're choosing, this is a combination, the order doesn't matter, so NCR, combination. We're choosing how many winners? Let's see here, 5 winners are going to be chosen. So I could use my calculator or do this the long way. I'm going to do this the long way, so I'm going to start at 23 and we have to put 5 numbers down because we're choosing 5. So 23, 22, 21, 20, and 19. And we're going to divide by starting at 5 because we chose 5 people. 5, 4, 3, 2, 1. All right. Let's multiply this out here. 23 times 22 times 21 times 20 times 19. It's going to be a big number. Oh yeah. So let's see. We have 4,037,880 for the numerator, and 120 when we multiply out the denominator. And so that tells us that our answer is going to be 33,649 different ways that 5 people can be chosen if 23 raffle tickets are sold. And our last problem here, it's going to be a permutation question. This question says there are 21 dogs competing in a dog show. First place, second place, and third place will be chosen, as well as a notable mention. How many different ways can these dogs be chosen? I know from this problem that it is a permutation because the order matters. And I know that the order matters because they're giving out places. Okay, if I get first place, that's different than getting second place. They're not equal to one another. So I care about the order. I care if I'm in first as opposed to second, as opposed to third, or even notable mention. So since I care about the order, it's a permutation. So let's go ahead and do this problem here. How many dogs do we have to choose from? Well, there are 21 to choose from. We said it's a permutation, and we can get first, second, third, or notable mention, which means we're breaking this into 4 different groups. So we're going to do this permutation here as 21 times 20 times 19 and then times 18. We don't have to do any division because this is not a combination, it's a permutation. So we have 21 times 20 times 19 times 18. And that tells us that our final answer then is going to be 143,640 different ways that we could get the first, second, third, and notable mention from a competition having 21 dogs.